Good morning, students. In previous class, we have studied resistive circuit, inductive circuit. Okay. In resistive circuit, voltage and current are in phase. In resistive circuit, in inductive circuit, current lags the voltage by at an angle of 90 degree. Okay. Here today we have to study capacitive circuit, AC through capacitive circuit. In place of resistor or inductor, we have to connect the capacitor and input supply. Then it is called capacitive circuit. Okay. Here we have connected capacitor C and input supply voltage V, Vm sin omega theta. Okay. Then we have connected the capacitor across the voltage source. See here what happens, current and voltage waveforms. In resistive circuit, current and voltage are at same angle. In inductive circuit, current lags the voltage by 90 degree. Here in capacitive circuit, current leads the voltage by 90 degree. Means first we will get the maximum value of current, then we will get the voltage. Therefore, the capacitive circuit, it is a voltage waveform. The current leads the 5 by 2. 5 by 2 means 90 degree in the capacitive circuit. Okay. This is the waveform of voltage and current. It is waveform of voltage. It is waveform of current. Okay. Then in vector diagram, it is voltage waveform at 0 degree angle and current leads the 90 degree by voltage leading. In resistive, both voltage and current are in same phase. In inductive, current lags the voltage by 90 degree. In capacitive, current leads the voltage by 90 degree. Okay. How do we have to write the points? A simple circuit, it is a one simple circuit, pure capacitor of C farad. C farad means farad is the unit of capacitor. Here we are considering one C farad capacitor connected across a voltage given by the supply voltage or the voltage Vm sin omega theta. Okay. When we connecting the Vm sin omega theta, the current I charges. Charges means capacitor is a charging device. It will charges the capacitor C, the instantaneous charge Q on the plates. Means these two are the capacitor plate. It is positive, negative or negative, positive, any plates. What happens when you giving the input supply Vm sin omega theta, the current I flows in the circuit, the capacitor will charge us. Okay. Then the capacitor charge we can write Q is equal to C into V. Q is the charge stored in the capacitor C with respect to the supply voltage V. Then we have to write C is equal to Vm sin omega theta. Okay, V is the supply voltage. We have to write in Vm sin omega theta. The current is rate of flow of charge. With respect to the value of supply voltage, the current will be changes. I is equal to dq by dt. What is Q? Q equal to C into V. V means input supply voltage Vm sin omega theta. Substitute the value of Q, then C Vm sin omega theta. C is equal to Vm dt sin omega theta. Therefore, I is equal to C capacitor charges with respect to charge Q with respect to supply voltage Vm omega cos omega theta. Then we have to write, see here, what is C? C is the capacitor value. Okay, C we can write it as 1 by omega C, because in resistive circuit the capacitor has some opposing force, that is capacitive reactance. Therefore we can write I is equal to Vm as it is. C we have to write 1 divided by omega C. Cos omega t we have to write sin omega t plus pi by 2. Why we are taking the plus pi by 2? It is a leading. How much value it is leading? It is leading at an angle of 90 degree. Therefore Im we can write it is a resistor. Okay, 1 by omega C, it is a resistor. Which type of resistor? It is a capacitive reactance. It is a capacitive reactance Xc. Okay, therefore Im we have to write. See here, why we are writing Im is equal to Vm divided by Xc. 1 by omega C means Xc. In place of Vm Xc, or in place of Vm 1 divided by omega C, we can write Im sin omega t plus pi by 2. Okay, then Xc is equal to 1 by omega C. See here, 1 by omega C is equal to Xc. Same here we are placing Vm in place of Vm divided by Xc. What is omega? Omega means 2 pi f. Therefore 1 divided by 2 pi fc. Okay, the current leads the voltage applied by 90 degree. Here in capacitive circuit, current leads the applied voltage by 90 degree. The waveform of voltage and current, the current waveform start earlier by 90 degree, means in capacitive circuit current starts at an angle of 90 degree. How the capacitor, the current starts 90 degree means the charge, the capacitor will stores the charge. Therefore in power, see here, it is voltage waveform, it is voltage waveform, dotted it is showing current waveform. This is the power waveform. How we will get the power? See here, it is positive, it is also current or positive, voltage or positive, then you will get the higher value of power. Okay, the power P is equal to Vm Im2 sin 2 omega theta. This is the capacitive circuit. In your examination the question asks, explain pure capacitive circuit. Then you have to draw the diagram. Capacitor across the supply voltage in current waveform at an angle of 5 by 2 90 degree advance the supply voltage. Then you have to draw the vector diagram. You have to write simple two words. When you input supply Vm is connected to the capacitor, the current I flows, the capacitor will charges, that is Q equal to CV, C is equal to V is Vm sin omega theta, I is equal to dq by dt. Then Q is CV V omega theta, then V Cm we have to take separate here, d divided by sin omega theta. Differentiating sin omega theta, we will get omega cos omega theta. Then 1 by C we have to write 1 divided by omega c. Why we are writing 1 by c omega? Actually Vm divided by Xc. Vm divided by Xc means 1 divided by omega c. Then what is Xc? Im divided by Vm is Xc. Therefore we have to write Im sin omega theta plus pi by 2 90 degree. Then we have to draw the power waveforms. Okay, this is the regarding the capacitive circuit. In previous two classes we have finished resistive circuit, inductive circuit, capacitive circuit. But these three circuits are very important. We have to study next RL circuit, RC circuit, RLC circuit. RL circuit means resistive inductive circuit, resistive capacitive circuit, resistive RLC, resistance, inductance, capacitance. In place of we are connecting one resistor, one inductor, one capacitor. Therefore we have to know the value. What are the important points in these two means? Here we have make the one comparison table. You have to remember these points. Then we have to study the next RL, RLC circuit. In resistive circuit, the voltage across the resistor is connected. In resistive circuit, current and voltage are in same phase. Then we have to write V, it is a small v. V is equal to Vm sin omega theta. In this, I is equal to Im sin omega theta. Means the angle both are same angle, 0. Same angle, both are 0 maximum or 0 maximum minimum. Any value, voltage and current are in phase. Then we can call it is a resistive circuit. Both voltage are in, current are in phase. Okay, then it is called unity power factor. The power factor in resistive circuit is unity. It is very important point. Okay, next what happens the power? The power will be only positive will be appears and the power will be multiplies. Then we can say it is a current, it is voltage, it dotted is current, then both combined together we will get the maximum value of power. Okay, this is in resistive circuit. Next, in inductive circuit, current lags the voltage by at an angle of 90 degree. So here it is voltage waveform, it is current. What happens here? V is equal to Vm sin omega theta. Okay, it is starting from 0, therefore omega theta. But current it will lags. Lags means I is equal to Im sin omega theta minus pi by 2. Minus pi by 2 means Im sin omega theta minus 90 degree. Means voltage at an 0 degree and current lags at of 90 degree. Current lags 90 degree by voltage, therefore it is inductive circuit is also called as lagging power factor. See here it is voltage waveform, it dotted is current, it is lagging of pi by 2. Then power will be, see here it is negative, it is positive. Multiplying these two voltage and current we will get the negative value of power. Here both are positive, we will get the positive value of power. Means total power is 2 plus. Here in inductive circuit power will be 2p, 2 power. Okay, in capacitive circuit current leads the voltage by at an angle of 90 degree. Therefore here it is voltage, the current it will leads at an angle of 90 degree. Then V is equal to Vm sin omega theta, I is equal to Im sin omega theta plus pi by 2. Plus pi by 2 means 90 degree. Current lead 90 by voltage, leading power factor. Same here, power will be multiplication of voltage and current, then you will get the power. Okay, thank you.